1, 2. Hello, everyone. My name is Sohan Maheshwar. I live in Amsterdam. This is my first time in Moldova, so thank you for having me. Yeah. I've been in the industry and in cloud for 16 years now, including a long time at Amazon and AWS. And I have a silly question, but how many people here have heard of AI or are working with AI? Yeah, everyone. Yes, of course. And I'm here to talk to you about something that you will learn today, which is how authorization works under the hood at Google, but also a little bit about OpenAI. I like to think of 2025 as the year where we all added AI in production. Enough of testing and proof of concepts, and we added it via things like LLMs, agents, applications, but also this thing called RAG pipelines. RAG stands for Retrieval-Augmented Generation, and it's a technique, it's an architectural decision where you can have like a corpus of documents in your company, say 1 million documents, and instead of training a model on these documents, you can augment an existing model with this knowledge of these documents. And it's very popular right now. If you've used a chatbot in a company, it's probably using a RAG pipeline behind the scenes. But with this addition of AI, there also comes security risks. In fact, some of you all might have heard of this foundation called OWASP, which stands for Open Worldwide Application Security Project. And last year, they published a top 10 for LLM security risks. And 3 of these, like disclosing sensitive information, giving excessive agency to an AI agent, but also embedding weaknesses in vectors, all of these can be solved by proper authorization. And that's what I'm here to talk to you today. This is typically what a RAG pipeline looks like. You have what's called an ingestion phase. So say you have a base of documents or data, and that is pre-processed, it's cleaned up, and it's sent through an embedding model. In short, an embedding model is a way to convert words and images into numbers because, hey, computers like numbers, and these are called vectors. And you embed that with something called metadata, which indicates which data came from which document. And that is stored in a database. Then, of course, a user queries a document or asks for a question, which also goes through this embedding model. It goes through the vector database, and all of the relevant embeddings are sent to an LLM, and the user gets an answer. You get an answer. There's something missing in this document or in this image, which is there is no security. What if I opened up the chatbot at my workplace and typed in, how much does my CEO earn every month? I shouldn't be able to see that answer. But with this model, you might just. So let's talk about how you can add authorization. I'm going to talk a little bit about this word, authorization. In our industry, when we say the word auth, sometimes we mean authentication, and sometimes we mean authorization, and they're 2 different things. Authentication is identity, who you are. So if you've ever logged in with LDAP or Okta, that is authentication. Authorization is what comes after that, which is permissions. What can you access? And in the past, we have done it with things like a list. You have a large list of all the people who can edit this document. Not a very scalable model. The industry came up with something called RBAC, or role-based access control. You might have this in your company, where you have a role like DevOps engineer, which means you can check in your code pipeline. Or you have a role like sales, which means you can access sales reports. But again, not very scalable. What if someone in sales wants to check in code? Doesn't happen often, but it could. And that evolved to attribute-based access control, where everything is based on an attribute, like location or email. And at the decision point, all these attributes are checked, and you get a yes or a no. So sometime in the 2010s, Google wanted to change how they did authorization to fit their needs. And that is billions of users, billions of documents. And these methods didn't work for them. So they popularized a new way of access control called relationship-based access control. And we know this because in 2019, they actually published a white paper called Google Zanzibar. You should check out this white paper. It's a 14-page paper, and very enjoyable read. And in it, they describe exactly how authorization at Google works. And their system is called Zanzibar. Even back in 2019, they could do more than 10 million client queries per second. And I'm sure that number has increased since then. So what is RBAC, or relationship-based access control? Well, everything is a relationship between one thing to another. You have a person and a folder, and there's a relationship between them. You have a folder in which there's a document, and there's a relationship in between, and hence, there is a relationship between the person and the document. And what can you add relationships in? Well, one has to be a user. So if you have a Google account, you're in their authorization system, and anything, any object could be a relation to a user. So it could be a photo, a YouTube video, Google Maps, document, any of that. So you have these users and objects. How do you tell a system, in this case the backend, that this relationship exists? So these relationships could be things like a member of a group or an uploader of a video. And to tell a system, they came up with this thing called a relation tuple. How this works is you read what's onto the right of the hashtag. So in this case, user number 3 is the owner of document 123. So if you've ever created a Google Doc, something like this has been written in their system. And this is flexible, because objects can also relate to other objects' relations. So in this case, group security is a member of group engineering. And if there is a change in an organization, it's just about writing a new relation tuple. So what are we doing with this data, these users, these objects, these relations? Essentially, what happens in the Google backend is a graph is created with all of this data, where users, objects, and relations are different nodes. So going for an example of Google Docs, you have a document, you have readers, that's Fred and Kim, and you have a writer, that's Jill. Notice the dotted line between reader and writer. This indicates that all the people who can write to a document can also read a document. Say the requirement changes and you have to add an organization to this particular format. It's easy. It's just adding a new node to a graph. Here we add a new org, and we say all admins are writers. So when you click on a Google Docs link, and sometimes you say access denied, what is actually happening behind the scenes? Well, if you can traverse the graph in a unidirectional way, that means you can access this document. So say a check comes in to see if Jill can read some document. Check the graph to see if there's a way you can go from some document to Jill via the read permission. And in this case, yes, there is. There is a way to go from some document to Jill, and hence, yes, Jill can read this document. Similarly, see if Fred can write to this document, and the answer is no. There's no way for Fred to write to this document because you can't traverse this graph. And these systems, the Zanzibar-like systems, shine when you need low latency, when you have a high throughput of checks for whether people can access this or not, and you have global scale. Because remember, this was built for Google level of scale. And guess what? RAG pipelines need exactly this. RAG pipelines have lots of checks with permissions that change often. They need low latency, and they need consistency of relationship data. So we have this new way of doing authorization. We have this new technology. It works well. But hey, this is a Google thing, right? Like, what do we do with it? Well, in 2019, there was this white paper that they launched, and everyone in the security world were like, whoa, this is very cool, and this is cutting-edge technology. In fact, companies like Airbnb and Carta, they re-architected their entire backend to model this particular system. At the same time, there were open source tools that started being built based on the Google Zanzibar implementation. And right now, these are the 4 ones that are popular. There's SpiceDB, Ori, OpenFGA, and Permify, all open source on GitHub that are based on the Zanzibar system that you can use for authorization. I'll talk a little bit about SpiceDB. Essentially, again, started about 5 years ago with contributors including Adobe, Netflix, Reddit, and so on. The one metric that matters to us as developers, of course, is GitHub stars. So there are 6,000 GitHub stars, and if you feel like it, you could maybe give us more. And essentially, SpiceDB is an open source implementation of Zanzibar. It is a database, but it's not a general purpose database. It's purely meant for authorization queries. It's written in Go, and you can ask questions like, can this person take an action on this resource? So can Sohan view this document? You can also ask questions like, give me all the people who can view this document, or give me all the people who can check in code to this repository. You can also do the reverse lookup and say, give me all the repositories someone can access. All of this is available via API. So let's talk about how you can use this new technology of a Zanzibar-like system to secure RAG pipelines. There are two ways you can do this and two techniques. The first one is called post-filter authorization. So here, look on the start of the left, the user makes a query. This query goes into an embedding model, and that embedded query is then passed on to your vector database, and you get the relevant context. Once you get this context, with each of the document that you've gotten this information from, you can make a check permission request to your Zanzibar-like system. So say you get information from 3 documents. Each of those have a metadata ID. And you query the system saying, hey, can this person access these 3 documents? And maybe they can access 2. Based on that, you can send those 2 documents to the LLM to process. So that way, the user is not getting information from documents they cannot access. Now, this method works well when you have a high positive hit rate in your documents. So say you have 100 documents, and you have to make a check, and you have a high positive hit rate, this method works well. But say you have 1 million documents, it's hard to sort of do that check. So in that case, you would use a pre-filter authorization. This is a slightly different approach where a user makes a query, and the query goes through this embedding model, and that embedded query then is first looked up in your Zanzibar-like system. So you ask the system saying, give me all the documents that this user has access to. This is different from a checking permission. This is a lookup of saying, give me all the documents that a user has access to. And you get a bunch of documents. Those documents are then used as a filter in an embedded query that you would send to a vector database. The vector database then would remove the relevant embeddings and then send that to a large language model. And then you would get a response. So there are 2 ways you can actually do this, either do a post-filtration or do a pre-filtration. In the real world, this would look something like this, where for your Zanzibar-like system, you could use something like SpiceDB. For your vector database, you can use something like pgvector or Pinecone. And of course, for your LLM, you can use OpenAI or really any large language model that is available right now. You might think, oh, this sounds good. Is anyone actually doing this in production? I have a question for you. Who here uses ChatGPT? Anyone? Yes, everyone, of course. We all use ChatGPT. ChatGPT is my best friend. If you've seen this new feature in ChatGPT called connectors, if you click on that little plus button, you've seen a new feature that actually enables you to connect ChatGPT to Google Drive, SharePoint, Dropbox, Box, and more. That feature actually uses SpiceDB at scale to do exactly what I described. So yes, it is being used in production, and it is being used at the scale of OpenAI. In fact, they're using this to process 37 billion documents, which is a pretty large number. And this is for 5 million users. For those of you all who have worked on AI and security, this is a complex problem in an organization. So say you have a large organization, billions of documents, and you have connectors to 15 different document products like Google Drive, OneDrive, and SharePoint. All of them do security and authorization differently. So an earlier approach would be to write custom code for each of them, maintain each of these libraries, have teams that look at it, have it as part of a pipeline, and any change would involve making change to each of these different ones. But the Google Zanzibar system is very flexible to mimic any other schema. Right? Essentially, you can model how another authorization system looks with something called a schema. So it is as simple as defining what the third party looks like, implementing that in your system, and centralizing your authorization. And that's how ChatGPT was actually able to do it for 37 billion plus documents right now in production. And there is a second order effect to this as well. The first order effect is, well, you have secure RAG pipelines. Your users are accessing documents only that they are supposed to access. But at the same time, you have an audit log of everything that's happening behind the scenes. So say someone is added to a document, or say an organization is removed from a document, there is an audit log for each of these steps that happen, which in the enterprise is important. And of course, you're optimizing how fast your RAG pipeline is. Instead of querying millions of documents, you only query the documents that are relevant to the user. So you're really building efficient RAG pipelines at scale. I have a little demo I can show you, not on stage, but off stage. So if anyone is interested, I have my laptop with me. I can show you the code of how this works. I'll open up a Jupyter notebook, and we can go through it. There's also some swag I can give away. But if you would rather do this on your own time, you can see a Jupyter notebook that I've linked on GitHub, where you can see exactly how this method works. So you literally just download a Jupyter notebook, and you can run it, and it works that way. And if you're interested in things like distributed systems and security at scale, do check out the Google Zanzibar paper. It's a 14-page document, which is very readable. So maybe on the way back home, you can check it out. And if you want to download today's presentation, you get an email link here. But also feel free to connect with me on LinkedIn or right after this talk. I'm also here for questions, and I really hope you learned something new today. And I'm excited to see what you will build in the future. Thank you very much.